Day 265 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 918, maximum sum circular subarray. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. So let's get into it. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's get started. Question says, given a circular integer array nums of length n, return the maximum possible sum of a non-empty subarray of nums. A circular array means the end of the array connects to the beginning of the array. Formally, the next element of nums I is nums I plus 1 mod n, and the previous element of nums I is nums I minus 1 plus n mod n. A subarray may only include each element of the fixed buffer nums at most once. Formally, for a subarray nums I and nums I plus 1 up to nums j, there does not exist a I which is less than or equal to k1 or k2 which is less than or equal to j, with k1 mod n equals k2 mod n. All right, y'all. So let's break that down. It's pretty simple though once you get it. A circular subarray just means we can connect this 2 to this 1 and we can include that in our output when we are calculating our sum. However, let's break it down a little bit further by looking at example 1 so we can know exactly what it is that they're talking about, right? So in example 1, we have the input nums equals an array of integers 1, -2, 3, and -2. The output is 3. Explanation says subarray 3 has a maximum sum of 3. So this is a kind of a weird example because in this example, the output is 3. But the output is 3 because even if we add this 2 to this 1 to this 2, that will still give us, so -2 plus 1, that give us -1, then plus -2 again, that give us -3. It's still going to be less than 3, right? So the overall maximum sum of this example is just 3. Even if we add other elements together, it still won't get us more than 3. So that's why the output is 3. Let's look at example 2 where we actually have to use the circular subarray that they want us to, which will help it make a little bit more sense, right? So in example 2, we have the input nums equals 5, -3, and 5. The output is 10. Subarray 5 and 5 has a maximum sum of 5 plus 5, which equals 10. So in example 2, this is the example where they actually use the circular array that they're talking about in this question. I don't know why they started off like that with example 1, but who cares? It's their world. We just live in it. So in example 2, you can see they took this 5, and even though there's no elements after this 5, it's like we just went in a circle and we went back to this index 0 at the beginning of the array, and we can include this 5 in our output as well, right? So we just add this 5, then imagine us going in a circle. Imagine this is just one big circle, and we go from this 5 to this 5. And that gives us 10. If we want to take it one step further, right, say we went from this 5 to this 5 to -3, that would give us 7, which is not bigger than 10. So that the maximum sum that we can achieve is 10, and that's just by adding this 5 to this 5. Even if we added -3 plus 5 as well, that'd give us 2, but that's still not greater than 10. We want the maximum sum, and the maximum sum comes from taking this 5, going in a circle, coming back around to this 5, and that gives us 10. So let's look at example 3 where it's just all negative integers, right? So in example 3, we have the input nums, which is an array of integers -3, -2, and -3. Again, the output is -2. The subarray -2, explanation says subarray -2 has a maximum sum of -2. So as you can see, even if we add all these together, right, if we add all these together, that gives us -8. If we add this -3 plus -3, that's just going to give us -6. So just -2 by itself, that's smaller than both of the -3s. So -2 by itself is, excuse me, y'all, the maximum sum, similar to how we did in example 1 where 3, we only need one integer to have the maximum sum. It's the same thing, and in this case the maximum sum is -2. So now that we understand what the question is asking, let's get into the fun part, the actual code. We're going to use something called Kadane's algorithm, which runs on big O of n time, which is extremely efficient. So let's get started so we can figure out how we're going to do that. Now, the first thing we need to do is we need to initialize a global sum to the first element of the array, right? And this will hold the largest subarray sum found so far using the standard Kadane's algorithm. So in order to do that, we are just going to come right here and we are to declare a variable. We call it global. We call it global max. And we'll set that equal to nums square bracket 0. Boom. Now we need to initialize a global minimum, and this will hold the smallest subarray sum found so far, which will be used to calculate the circular sum when we need to. So in order to do that, we're just going to declare a variable. We'll call this one global min because it will be the smallest. So we'll say global min, and we could set that to nums square bracket 0 as well. Boom. Now we need to initialize the current maximum sum, and we're just going to set that to 0, and that will keep track of the current maximum subarray sum. So in order to do that, we can just say declare a variable, call that cur max. We'll set that equal to 0. Then we have to do the same thing and initialize for the minimum sum, and this will keep track of the running minimum sum. So in order to do that, we'll just say var cur min, lowercase I min. We could set that equal to 0 as well. Now we need to initialize the total sum of the array, and this will hold the sum of all the elements in the array. So in order to do that, we could set that to 0 as well. So we say var total equals 0, just like that. Now let's get started. It's time to iterate through each element in the input array. So in order to do that, we could just say for n nums. Then we open up the brackets. Let's get into it. Now we need to reset the cur max to either the current element n or the current subarray sum, which includes n, and whichever is larger, this will ensure that the current subarray becomes negative. If the current subarray becomes negative, we start from n. So in order to do that, we're just going to say cur max equals max, open up the parentheses, whichever one is bigger, cur max or 0. So cur max, comma 0. Then we're just going to come down here and we'll say then we'll say cur max plus equals n. Boom, just like that. Now we need to do the same thing for the min and reset the cur min to either the current element n or the current subarray sum including n. And whichever is smaller, this will ensure that the current subarray becomes positive, or if the current subarray becomes positive, then we start fresh from n. So in order to do that, we'll come right here and we are going to say cur min equals min, open up the parentheses, cur min, comma 0. Then come down here and we'll say cur min plus equals n. Boom. Now we need to add the current element, which will be n, to the total sum of the array. So then we could just come down here and we could say total plus equals n. Boom. And now we need to update the global maximum sum to be the larger of itself or the current running sum, which is cur max. So we need to update the global max to be the whichever larger, global max or cur max, right? In order to do that, we could just say globe max equals, then we say max, open up the parentheses, globe max, comma, cur max. And once again, this is going to update globe max to be whichever one is larger. Now we need to update the global minimum as well to see which one is smaller, the global minimum or the current minimum. Similar to what we did with the globe max, just for the which is smaller. So we could say globe min equals the min of globe min, comma, cur min, just like that. Now, if the global minimum is negative, it means all elements in the array are negative. In this case, the largest possible subarray sum is the single largest element, similar to how we did in example 3, where -2 was the single largest element, right? So then we could return the globe max directly, and a circular sum won't even need to be formed here. So in order to do that, we just come right here, and we're going to start our if statement. We'll say if globe max is less than 0, boom. That means they're all negative. The whole array is negative. We could just return globe max. Boom, just like that. Then we're going to come down here and we're going to say else. And so otherwise, we're going to compute the maximum subarray considering the circular. We need to consider the circular pattern that they're trying to give us, or the circular array that we're working with. And that's going to be calculated as the total minus globe min. And then we'll just take the larger of that. So we're going to say return max, open up the parentheses, globe max, comma, or total minus globe min, just like that. Now that should be all she wrote, y'all. Wasn't too difficult at all. That code wasn't too difficult. So let's run it. Use the Cadene's algorithm. Let's see. Ooh, okay. Can I find globe max in scope? So you mean I've been spelling this wrong this whole time? How we spell it? Oh, alright, well, since I put globe max, all those, let's just turn this to globe max and turn this to globe max instead of global max. Alright, let's run it again. If you had global max, that's fine. Either one will work. Just make sure that the names of the variables match each other. Just make sure these names match all these names down here, like these globe, you know what I'm saying? Whichever is easier for you. But this was accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. Because you know how LeetCode gets. You never know. You got to always submit it. Always run before you submit it. And look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. That's that big O of N time that I was talking about. That's some fast stuff. That stuff goes fast. Hope you could keep up. Now, before we leave, make sure y'all get one more look at the code. One more look at the code. Bada boom, bada bing. Read it, learn it, love it. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.